In lecture 1, we discussed how we check for linearity property of a system. Let me recall it again. Uh, in order to check for it, we need to have two equations. One is uh, desired output of a linear system, and we call it as equation 1. And we need to get one more equation, which is system output, called as equation 2. If equation 1 is equal to equation 2, then the system is linear. Otherwise, equation 1 is not equal to equation 2, the system is non-linear. So now we'll take up one problem and we'll check for linearity property of a system. Okay, first one. The system is y of t is equal to g of t into x of t. Before I solve the solution, we know that the system can be represented in a graphical way as something like this. We have a system x of t, we are feeding it to that system. We are feeding this x of t to the system and we get y of t. And what is y of t? Y of t is g of t into x of t, right? And one more way to represent it is transformation of x of t. What do you mean by this? I have a system which does some transformation t, so I am feeding x of t as an input to this system and I get output as y of t, right? And I can write it as transformation of x of t is equal to y of t. And what is y of t? Y of t is g of t into x of t, right? So each and every time when I take up a problem, I will convert the equation, the system something like this to system something like this, so that it's easy for me to convince you what's happening in each and every step. Okay, we'll solve it. So solution. Now, as per the statement of the linearity property, you feed the individual input. Say if I feed x of t, I get y of t, right? But for the system, if I feed x1 of t, I should get y1 of t. Correct, no? But if I scaled it, if I feed a scaled input, which is a into x1 of t, so output should also be accordingly scaled, right? Which is equal to a times y1 of t. If I give a scaled input, I should get scaled output. Similarly, if I feed one more scaled input, which is b times x2 of t, what am I supposed to get? It is b times y2 of t. For every scaled input, I should get scaled output, right? Now, if I combine these two and feed it to the system t, which is a times x1 of t plus b times x2 of t, output should also be combined form, that is a times y1 of t plus b times y2 of t. Okay, so this is actually as per the statement of linearity property. As I told you before, I need to get, so what is the first step? So first step is to get desired output of a linear system. Okay, so as per the system definition, transformation of x of t is equal to y of t, right? And transformation of x of t is equal to g of t into x of t. Why? Because system is y of t is equal to g of t into x of t. Now if this is the case, what is transformation of x1 of t? It is nothing but g of t into x1 of t. What if I scaled the input? Transformation of what is a into x1 of t? So I should get g of t into, so instead of x1 of t I should write a into x1 of t, right? So this is the scaled input. For this scaled input I'm getting this is as the scaled output. Now similarly, what is the transformation if I feed another input x2 of t? What is the output? G of t into x2 of t, right? And what if I scale it? B times x2 of t. What are the output I'm getting? It is nothing but g of t into b times x2 of t, right? So if one input scaled, this is the output I'm getting. The another input which is scaled, this is the output I'm getting. So when I combine it, which is nothing but a times x1 of t plus b times x2 of t. Shall I write it as a times y1? Not this one. So this equation. Shall I write it as a times y1 of t? Why did I write this? Because linearity property says like that for every scaled input I should get scaled output a into y1 of t. And what is the scaled output? It is nothing but g of t into a times x1 of t. Okay, and similarly this is the scaled input. Another input, so I can write it as b times y2 of t, right? So for every scaled input I should get scaled out. Okay, now if I combine this scaled input I should get a times y1 of t plus b times y2 of t, right? Again as per the definition of linearity property, and this is equal to what is a times y1 of t, which is nothing but g of t into a into x1 of t plus what is b times y2 of t, which is this g of t into b times x2 of t. I'll just rearrange this a times g of t into x1 of t plus b times g of t into x2 of t. Okay, so this is the output I'm expecting, desired output I'm expecting for a linear system. So we shall call it as equation 1. So we need this equation back. First, we'll check the system output now. Now, the second thing I need to do is to get system output. So in order to get the system output, we need to understand the system first. So what is the system? So it is y of t is equal to g of t into x of t, right? So I can write it as transformation of x of t is equal to g of t into x of t. Transformation of x of t is y of t and y of t is g of t into x of t. Now what is the system doing? So let me put it like this. I have a system t. If I feed this as input, I'm getting output y of t, which is nothing but whatever the signal you feed x of t, for that signal the system is multiplying a arbitrary signal g of t. And what is this g of t? We don't know. It can be anything. Okay, let me convince you graphically. Say I'm feeding a sine wave to the system, scaled version of sine wave. Okay, so I'm feeding a sine wave t. This is the signal I am feeding to the system. Okay, and we'll assume that g of t is a unit step function, and I hope you know what is unit step function. It is defined for t varying from 0 to infinity and its amplitude is 1. So what is the system output I am getting? System output is nothing but what? This unit step function is getting multiplied with the sine wave x of t, right? How does it look like? So this signal multiplied with this signal. So for negative values of t, it is 0. 0 multiplied by anything is 0. So I get 0. And for positive value of t, 1 multiplied with this signal, I get this signal back. So which is like this. So this is the system output. If I feed sine wave as the input to the system, and if we assume that g of t is a unit step function which is u of t. Okay, I hope you got convinced what's happening to the system. So this can be any signal. This can be a sine wave, square wave, triangular wave, or our speech signal. Again, g of t can be any arbitrary signal. So but whatever the signal you feed, that is multiplied with g of t and resultant is our y of t. So this is what happening to the system. Okay, now so if instead of feeding x of t, I feed x1 of t to the system. So what is the output? So whatever the signal I feed, for that signal this g of t is getting multiplied, right? So if I feed x1 of t, for x1 of t, g of t is getting multiplied. Now if I feed scaled version of x1 of t, what is the system doing? So for the scaled version of this input signal a times x1 of t, say if this is scaled by a factor of a, for that signal g of t is getting multiplied. Okay, so similarly if I feed x2 of t to the system, what I am getting? So x2 of t gets multiplied with the signal g of t, right? And if I feed scaled version of x2 of t, b times x2 of t, so for that scaled version of x2 of t, again g of t is getting multiplied. Now I'll combine these two. So transformation of a times x1 of t plus b times x2 of t. Okay, so as a whole, this is one signal. Okay, a times x1 of t plus b times x2 of t, as a whole this is one signal. So this is the signal I am feeding to the system. So what is the output from the system? So whatever the signal I feed, now this is the signal I am feeding, which is a times x1 of t plus b times x2 of t. So for this signal g of t gets multiplied. Okay, so whatever the signal you feed, g of t is getting multiplied. Now if I simplify this, g of t into a times x1 of t plus g of t into b times x2 of t, I'll rearrange it, a times g of t into x1 of t plus b times g of t into x2 of t. So this is the system output, which I call it as equation number 2. Fine. So what was the desired output of a linear system? The desired output of a linear system was this, which is equation 1, and the system output is this, which is equation 2. So desired output and the system output are same. I'll write it here. Since equation 1 is equal to equation 2, desired output is the equation 1 is equal to system output is the equation 2. So therefore it's a linear system. This might feel difficult for you, but you need to practice to get used to it. I'll take up some more problems to convince you.